Unlike traditional employees or suppliers, crowdsourcing involves the division and distribution of a larger task to ordinary people, often those of less expertise and often within an online community. And such pieces of work are later then reassembled. Crowdsourcing is often more efficient and more cost effective than traditional employments and suppliers. It has also been viewed as an alternative source of labor, as well as a tool for the advancement of AI and machine learning, to the more expensive but accurate labeling of domain experts. Applications are now utilizing ordinary users to assign labels to objects, and such labeled data are used by intelligent algorithms to solve problems. Still, crowdsourced labels have some pitfalls, including the lack of expertise and determination of crowdsourced labelers, which results in inconsistent or lower quality labels and data, and consequently lower quality and less accurate learning models. So this poses the question and challenge of how that quality of data could be improved and how to use these noisy data to build a learning model.
Another section of the article goes over the concept of ground truth inference. It is essentially a process of estimating the true label of each example from its multiple label set. Conceptually, it seems like a simple task. However, constructing an algorithm needs other parameters to accomplish its task, and such as expertise of each labeler, difficulty of examples, etc. The algorithm goes through the set of noisy labels and uses the label that appears most often as the standard. This is ideal compared to integrating additional information beforehand, which would complicate the matter, such as labeling history, and so on and so forth. There are two main methods to go about how the algorithm can go: machine learning based or linear algebra based. Each of them complicated in their own way. Of course, it's not the only ways that ground truth inference algorithms can go, but
Crowdsourced data is a relatively new form of data collection and labeling, and though it has its perceived benefit of economic incentive, it has its obstacles, such as immature quality control and the possibility of lacking expertise. Still, it is cheaper than collecting data from experts, while still more expensive than social tax. To facilitate further research into crowdsourced labeling, some real-world datasets were made publicly available for research purposes, and the article describes three different open-source tools to analyze and work with these datasets. It concludes that CEKA might be the best tool as it can more easily integrate new code.
The importance of knowledge discovered from massive data is emphasized in a large number of intelligent systems. The learning models are continuously optimized as the accumulation of data. Constructing great learning models is one of the most maturely developed branches in machine learning. Although it has widely used, it still suffers from deficiency of the training data. The construction of crowdsourcing has greatly alleviated the contradiction between the demand of the learning curve and the deficiency of the training data. We can obtain plenty of labeled data from crowdsourcing systems in order to promote the research in this field. We need to summarize open, accessible, real-world crowdsourcing data sets as well as open source tools.
The U Chicago article discusses the racial biases that can occur within software programs. Software programs are becoming a prevalent mechanism for decision making in many fields. From healthcare to the judicial system, algorithms have been created to help industries make better decisions both for profit and for the community. However, as these mechanisms are still developing, there's many flaws that we are just now able to realize. One key issue is the racial bias that can occur when depending on these algorithms. The bias is rooted in the factors that the algorithms take into account when making the decision. In the specific algorithm discussed in the article, the main factor is healthcare cost. This factor is used to determine patient risk or who will benefit the most from a program. However, this is a biased factor, and that statement can be supported when looking at the statistics themselves. As quoted from Obermeyer, blacks at a given level of health end up generating lower costs than whites, and thus black patients were much sicker at a given level of the algorithm's predicted risk. By simply switching the factors to account for non-biased situations, such as costs that could be avoided from preventative care, we can create an equal playing field for all patients. I think it's important to understand that these biases are not caused by the people creating the algorithms. There are flaws that we can only now see because the system has been in place long enough for us to evaluate the data. And because we're learning as we go, it's important for us to fix these issues now rather than letting them become cemented into the way we use these algorithms, especially in healthcare.